Welcome to part 1 of this 3-part series. We are building a real-time multiplayer arcade game, but today in part 1, we are not building graphics, we are building the brain, the server. I'm going to show you how basic if statement and while loops power complex distributed systems. Now, I have a folder called Chicken Invaders, and then inside it I have one folder and one file, static and then main.py. Today we are going to be focusing on the main.py file, so follow along.
Disconnect. This creates two.
Think of our server like a hotel, and this dictionary is the guest list. Technically, it is a key value data structure. We use a unique ID as the key and their XY coordinate as the value, so the server always knows exactly where everyone is.
Yeah. Sorry. Mm. Allez, TV, teta, teta, teta.
Now, a WebSocket is like a phone call. The line stays open. To keep our server on the phone and listening, we use a while loop through. We intentionally create an infinite loop so that the server never goes to sleep. Now we're going to add the movement logic, the broadcast loop, and the mount the statics file at the bottom. So once we just did finish now is we added the WebSocket and the infinite loop. And the next thing now is to add the logic gates and basic broadcasting.
Yes.
P.
Bye.
Lagi piirkate. E.
When the server hears a message, it acts as a traffic cop. If payload says move left, we decrement the player's x-axis value by 5 pixels. Then we loop through our guest list and broadcast the new coordinates to everyone. The heartbeat test and the snapshots now. So, I know we did not complete this guy, but let's just do this. So I'm going to do dots.
No. Oh,
So I quickly created a command.txt file. So the reason why it is not working is because we did not run this command first. Now you can see we have our env file. Then we need to run this command next. Okay, it is not done yet. Just give it a minute and it should be done. Do not, it should not take this much time. You can see we have folders and files inside that it's remover. So with this command, we are creating a virtual environment so we can separate our program or this project from the rest of our files and folders present in our local directory. And to do that, we first have to run this command to create that virtual environment. It is not done yet, and then we now need to activate it. So by the time you activate it, you should see something like into bracket venv and then this directory in front of it. So it is still running creating the environment. And now it is done, and I've pasted my command, and now you can see this venv. So now we're inside the virtual environment in our terminal. So now the next thing I need to do now is I need to install some specific tools. I'll come here and write it and say pip install fast API uvcon and then web sockets.
Find us someone that's copied this
So you should start seeing some text on the terminal now that is installing. It should just take like a minute or so. Okay, you can see it now. It's creating fast API. So we're installing the tools that we need before we can spin up our server. And now the installation is done. So the last thing we need to do, I quickly do something, create the requirements file by saying pip freeze requirements .txt. Now we have our comments for them. So the last thing now is to now finally, so this is the content of the requirement.txt file, and we need to run the server. And to start the server, we say uvcon main path reload, and our server should be up and running. So before we wrap up part 1, we must prove our brain is actually alive. First, we activate our Python virtual environment, then we install our engine part, fast API, uvcon, and WebSockets. Now here's a pro tip in the real world. You must write down the exact tools used so that other developers can run your code. We do this by typing the pip freeze, this command, the pip freeze. It takes an instant snapshot of your environment, of our environment. With our tool save, let's spin up Vivicon. So we spinned up Vivicon main app. Reload. Look right here, you can see this log, and that is our application starts up complete. Our server is awake, the WebSocket route is open, and the port is listening at 8000. So let me see if I can get the port. So you can see now the port is listening at 8000. So, but because we have some uncompleted code is why we have this. We'll fix that later. I will just build the entire brain of our game. I will prove this is alive and listening, but right now it has no eyes and hand. Join me in part 2 where we build the data stage and paint our spaceship.